Assalamualaikum warahmatullahi ta'ala wabarakatuh, and hi everyone. See you again. In this video, we will continue to discuss the solution for SCORE Physics Set 1 for question number 6 to question number 8. Question number 6a. A mass is suspended vertically on the end of a spring and undergoes simple harmonic motion of frequency 4 Hz and amplitude 2 cm. At displacement y is equal to 1 cm, determine the velocity and acceleration of the mass. First step, you list all the information given from the question, and then to calculate the velocity of the mass, first we calculate the angular velocity, which is equal to 2 pi f, and then referring to the equation of the velocity of the mass, plus minus omega, so a square minus y square, we substitute the omega, a and y, so you will get the answer which is plus minus 43.53 centimeter per second. If you want to give the answer in SI unit, it also can. So the answer is plus minus 0.44 meter per second. To determine the acceleration of the mass, we will use the acceleration of the simple harmonic motion, negative omega square times y. So substitute the omega that you have calculated earlier, and also y, which is when the displacement is equal to 1. So you will get the answer for the acceleration, negative 631.65 centimeter per second minus 2. And for the SI unit, the answer is negative 6.32 meter per second minus 2. For question number 6b, figure 4 shows a displacement and graph of a simple harmonic motion for an object with the mass of 25 gram. Determine the angular frequency, equation for the simple harmonic motion, and also total energy. Okay, as usual, first step, you need to list the information given, and referring to the question and also graph given, we get the hidden info, where from the graph, at the y component, we get the amplitude, which is equal to 0.05 meter, and at the x component, we will get the period, which is period, the time taken for one complete oscillation, is equal to 4 seconds. First, we want to calculate the angular frequency. The equation for angular frequency, because we have the period here, so we can use 2 pi over t. Substitute the period, you will get the angular frequency is equal to 0.5 pi radian per second, or you also can give the answer as 1.57 radian per second. To write down the equation for the simple harmonic motion, first, we write down the general equation for the displacement of the simple harmonic motion. Y is equal to a sin omega t, and you need to identify the a, amplitude, and also omega. From our previous calculation, we can write down the displacement equation for simple harmonic motion as y equal to 0.05 sin 0.5 pi t. Don't forget to write down the unit where y is in meter and t is in second. For question number 6b3, to calculate the total energy, so we know the total energy for the simple harmonic motion is half m omega square a square. You just need to substitute the mass, omega, and also the amplitude. You will get that the answer for the total energy is 7.71 times 10 power of negative 5 joule. For question number 6c, the equation of progressive wave is given as y equal to 6 sin 2 pi times with 2t minus x, where x and y are in meter and t is in second. First part, we will determine the direction of the wave propagation, the wavelength, frequency, and the wave speed. Okay, when you get this equation for the progressive wave, what you need to do is, you need to expand the equation first. So now the equation for the progressive wave is actually equal to 6 sin 4 pi t minus 2 pi x. And referring to this equation, we can identify that the amplitude is 6 meter, omega is 4 pi radian per second, and the wave number k is equal to 2 pi per meter. To identify the direction of the wave propagation, we will look at the sign inside the equation. This negative sign shows that the direction of the wave propagation is from left to the right. So the answer is the wave propagation is to the right. For the wavelength, we will refer to the equation of wave number k equal to 2 pi over lambda. Because of that, when we substitute the k as 2 pi, we will get the lambda is equal to 1 meter. For the frequency, we will use the equation of omega is equal to 2 pi f, and we substitute the omega, which is 4 pi. So you will get the frequency, which is equal to 2 Hz. And for the wave speed, we know that the wave speed is equal to f lambda. V is equal to f lambda. Our f is 2 and our lambda is 1 meter. You will get that the wave speed is equal to 2 meter per second. To determine the particle velocity at x is equal to 2 meter and t is equal to 0.1 second. So first we write down the particle velocity. V is equal to omega a cos omega t minus kx, and then substitute the value for omega a and also the wave number k, and then x is equal to 2 meter and t is equal to 0.1 second also substitute in the equation. You can calculate. You will get the answer for particle velocity is 23.3 meter per second. Do take note that your calculator is supposed to be in the radian mode. Question 60. Two waves in the long string are given by equation y1 equal to 8 sine 2 pi t minus 2x and y2 is equal to 8 sine 2 pi t plus 2x, where y1, y2 and x in meter and t is in second. You need to write an expression for the new wave when both waves are superimposed, and you need to determine the amplitude for the stationary wave. For your information, when we have two progressive waves moving in the opposite direction and superimposed, they will produce the standing wave. The general equation for the standing wave is 2a cos kx sine omega t. To write down the expression for this standing wave, you need to substitute the value for a, which is a is equal to 8 meter, k is 2, and omega is 2 pi. So when you substitute this value in the standing wave equation, you will get the standing wave equation 16 cos 2x sine 2 pi t. And don't forget to write down the unit, where y and x is in meter and t is in second. Referring to the standing wave equation, we can identify the maximum amplitude for the standing wave, which is the amplitude is equal to 16 meter. For question number 6e, a 50 cm closed pipe makes a humming sound when the wind blows across the opened end. If the speed of sound is 340 meter per second, calculate the second overtone and also the fundamental frequency if the length of the pipe is half. First, list the information given from the question, and before you calculate the second overtone, you need to understand that for the closed pipe is odd harmonic. Because of that, n is equal to 1, 3, 5, 7 and so on. To calculate the second overtone frequency, we know that the n is equal to 5 because of for the fundamental frequency, n is equal to 1. First overtone, n is equal to 3. So the second overtone, n is equal to 5. And we will use the equation of nv over 4l. You substitute the n, which is 5. Speed of sound is 340 and L is 0.5, you will get that the second overtone frequency is equal to 850 Hz. For the fundamental frequency, if the length of pipe is half, we know that fundamental frequency N is equal to 1. We use the same equation and substitute. But in this case, our L is half from initial length, so our L is actually 0.25. When you calculate, you will get that the fundamental frequency is equal to 340 Hz. For question number 6F, a fire engine is coming toward a station emitting siren of frequency at 100 Hz. What is the possible frequency heard by a boy sitting in the station if the incoming fire engine is moving at 65 meter per second? Given the sound of source is 340 meter per second. Okay, referring to this question, we will use the Doppler effect equation. Okay, and referring to the Doppler effect, which is we want to calculate the apparent frequency heard by the boy. So, to identify the sign, either plus or minus, first we identify who is stationary. So, in this case, because of the boy sitting in the station, so V naught is equal to 0. And for the Vs, we refer to this concept. Vs now moving to the stationary observer, so the sign that we will use is negative. Because of that, the equation for the Doppler effect that we will use is Fa equal to V over V minus Vs times with Fs. And then substitute the value where V, speed of sound, is 340 and Vs is 65. The frequency of sound is 800 Hz. And you will get that the apparent frequency of possible frequency heard by that boy is 989 Hz. Question number 7a. An aluminium wire with diameter 1.5 mm is suspended from a rigid support with a load of 150 kg attached to its lower end. If the wire becomes 5.5 meter long, what is the initial length of the wire? So first, list all the information given from the question, and referring to the diameter, we can calculate the cross-section area of the wire. And then to calculate the initial length, we will use the equation for the Young modulus, which is y equal to FL0 over A delta L, and delta L is actually equal to L minus L0. And when we substitute the Young modulus as given in the question, and the value for mass G, and also A with the final length L, we will get that the initial length of the wire is equal to 5.435 meter. And then we need to calculate the extension of the wire. So extension of the wire is actually represent delta L. In this case, delta L is equal to L minus L naught, and our L is 5.5, our L naught is 5.435. Because of that, we will get that the extension of the wire is 0.065 meter. Question 7b. Two bars of the same diameter but different material are joined end to end as shown in the figure 5. One end of the bar is kept at 80 degrees Celsius while the other end is at 5 degrees Celsius. Determine the steady state temperature at the interface of the bars if the length of the first bar is same as the second bar. Given the thermoconductivity of the first bar is 240 watt per meter per degree Celsius, and the second one is 110 watt per meter per degree Celsius. So in this question, the things that you need to calculate is the temperature at the interface, or the junction temperature, or also called boundary temperature. And the condition given is the steady state. Steady state means that the rate of heat transfer through the first conductor is equal to the rate of heat transfer through the second conductor. And when we write down the equation, and we have identified the same value in the conductor in the bar 1 and bar 2, so we can cancel the value such as the negative sign, the A, and also the L. And then you can substitute the value, and the change in temperature Tj minus with 80 degree for the first bar, and for the second bar 5 degree minus with Tj, temperature at the interface. Because of that, when you calculate, you will get that the temperature at the interface is equal to 56.4 degrees Celsius. Question 7c. A block of gold has diameter of 12 times 10 times 8 cm at the temperature of 30 degrees Celsius. If the temperature increases to 120 degrees Celsius, determine the change in the volume of the gold block. Given the coefficient of linear expansion for the gold is 1.4 times 10 power of negative 6. First, we can calculate the initial volume for the gold block, which is equal to 9.6 times 10 power of negative 4 meter cube. Given the coefficient of linear expansion for the gold, 1.4 times 10 power negative 6. And we know that the gold will face the volume expansion. So referring to the relationship between the coefficient of linear expansion and the volume expansion, gamma is 3 alpha. So we can calculate the coefficient of volume expansion is equal to 4.2 times 10 power negative 6 per degree Celsius. After that, if you want to calculate the change in volume, you can use the equation of delta V equal to gamma V naught delta T. Substitute the value for the gamma that you have calculated, and then V naught and also the change in temperature. You will get that the change in the volume for the gold is 3.63 times 10 power of negative 7 meter cube. Question 8a. A tank contains 1 meter cube of helium at the pressure of 1.3 times 10 power of 5 Pascal and temperature of 350 Kelvin. The temperature of the gas increased to 370 Kelvin. What is the change in internal energy of the gas? Okay, firstly, we know the given gas is helium gas. So, helium is a monoatomic gas. The degree of freedom is equal to 3. This is because the internal energy depends on the degree of freedom. But referring to the question, you need to calculate the change in the internal energy. So the equation for change in internal energy is delta U equal to F over 2 N R delta T. Referring to this equation and also the information given from the question, we have no value for N, which is number of mole. So, if you refer to the given information too, we can calculate the number of mole by using the ideal gas equation, PV is equal to nRT. You will get that the number of mole is equal to 45 moles. Now, substitute the number of mole, 45. The R, the molar gas constant, is 8.31. Change in temperature, 370 minus 350. So we get that the change in internal energy is equal to 1.12 times 10 power of 4 joule. Question number 6b. The RMS speed of hydrogen molecule at a particular temperature is 1330 meter per second. What is the RMS speed of nitrogen molecule at the same temperature? Given the molar mass of hydrogen is 2 gram per mole and molar mass for nitrogen is 28 gram per mole. Referring to the question, we want to calculate the RMS speed of nitrogen. So the equation for the RMS speed that we can refer is Vrms is equal to SET3 RT over M. Because we want to find the RMS speed of nitrogen at the same temperature, so we know that the relationship between the Vrms speed or Vrms is inversely proportional to the SET molar mass. From this relationship, we can do the calculation using the ratio and substitute the molar mass of hydrogen, molar mass of the nitrogen times with the Vrms for the hydrogen. Because of that, you will get the Vrms for nitrogen, which is equal to 355 meter per second. Question number 8c. An ideal gas undergoes two processes AB and BC as shown in the figure. A heat of 4000 joule is dissipated from the gas in the process of BC. If P naught and V naught given as 1 times 10 power 5 Pascal and 0.02 meter cube, you need to calculate the work done for AB and BC. Also change in internal energy for BC. Okay, firstly, referring to the question, we know that QBC is equal to negative 4000 joule because of the heat is dissipated from the gas. To calculate the work done from for AB, it is referred to the area under the graph of AB. So WAB is equal to PVB minus VA. P is equal to 3 P naught and VB is equal to 2 V naught. Because of that, when you substitute the value of P naught and V naught, also VA, which is equal to V naught, you will get that the WAB is equal to positive 6000 joule. Positive work meaning that the work done by the gas. For work done from B to C, if you refer to point B and point C, the volume at VB is equal to volume C at point C. We said that the volume is constant. So if the volume is constant, the work done from B to C is equal to 0 joule. To calculate the change in internal energy for BC, we will refer to the first law of thermodynamic equation. delta UBC is equal to QBC minus WBC. Our QBC is negative 4000 joule and our BC, work done from B to C, is 0. Because of that, we get the change in internal energy is equal to negative 4000 joule. Negative for the change in internal energy, showing that the internal energy is decreasing. The change in internal energy is decreasing. Okay, that's it for the discussion of the solution for question SCORE Physics Set 1. I hope that you can do the revision and prepare for your PSPM. Thank you for watching and thank you for listening. Wish all of you good luck and all the best.